Okay, we're reviewing for the graphing test. It's graphing number 5. Graphing is usually people's happy place, and one of the nice things about it is, let's say you go brain dead and you forget what that looks like. You can always make an XY chart. Would you please make me an XY chart? For that, pick any numbers that work nice for X. I mean, look at the problem. Don't just blindly pick numbers. Look at the problem and go, okay, 2 to the what would be nice? Oh, that'd be easy. Find some points, graph them for me, and you'd have the most basic of all graphs. This would be like an R1 if there were such a thing. Pause for a second while I pull up some graph paper. Okay, here's some thoughts. First of all, I hope you stuck in X is 1. That'd be a nice, easy one. 2 to the 1 power is 2. Put a 1 in there. I get 2 to the 1, which makes it 2. So obviously 1 comma 2 goes together. What are some other nice points that you put in? 0 comma 1, excellent. 2 to the 0 power is 1, and that's a crucial point because every single exponential will go through that spot. 1 comma 2 is right here. Just those 2 dots alone don't tell me everything. I know generally these graphs look like this. Do you remember that? That's an exponential graph. All right. Because if you just connect those two lines, it'll actually be a straight line like this, and they don't look like that at all. So you need to generally know how the shape looks, right? Now, what other thing would you need? Otherwise, you're going to lose 5%. Asymptote. How many of you remembered to put in an asymptote on your graph? Only 3 people. All right. Maybe 4. If you don't have that asymptote, you will lose part credit. It's important. All right, that's your base exponential. Now let's say I'd make some changes because there wouldn't be anything that easy on the test. But there might be something this easy on the test. Let's say I throw in a negative right there, and then I put a plus 3. That's all up in the exponent, just to be clear. A lot of people think that that means the whole thing moves up 3, and it does not. If there was a plus 3 down here, it would move up 3. That plus 3 means move what? Left 3. Now, does the order matter? Can you just do it in any order you want to? The order does matter. That's a big deal in math, is the order. So we start on the inside, and on the inside stuff, there's 2 things. There's the flip, or the reflection. That's this part. And there's also the move left. Normally, things that are multiplied like this, negative, are first, but on the inside, you have to do the opposite of that. So this is left 3. So the whole graph moves left 3 first. 1, 2, 3. Now I'll move my dots with it. And 1, 2, 3. Okay, there we go. Now I've moved left 3. Now I do my reflection. Okay, and that goes straight across. Now it's on the inside here. It's high-vo, right? Horizontal on the inside and vertical on the outside, but there's nothing on the outside in the front or the back. So there's no vertical changes at all. It's all horizontal stuff. Now I'm going to take these points right here and reflect them across the line. That goes there. This one would go there. And can you see that it would look like that? Now just to clarify, there is no asymptote that is a vertical asymptote. This would cross this line and it would eventually, head further and further up and further left. Just like this green one, there's no asymptote running up and down. So this thing keeps going left, or keeps going right. So there is a reflection and a move to the left. Okay? Now, let's talk about the other kind. That was exponentials. How about logs? Would you just sketch for me what a log looks like? You got to kind of know how they generally look. That way when you're connecting your dots, you won't think I'm just going to draw a straight line through them. I would like you to be paired with somebody today, so I'm going to make it you two, and you're going to be, wait, I'm not going to do that, sorry. You two are going to be paired. You two, and you are going to be paired with him. Then it's going to be you two. You're forward and backwards. You two. You're going to be turning forward, and then you have to do double duty. Check with her also. All right. Compare your little sketches right now with the person who's guy just assigned you. This is a log graph. Okay. Remember me telling you that it's sort of like a tree being blown over in the wind? Because that's what a log is. After a tree's blown over, you have a log. Okay. Anyway, did any of you remember to put an asymptote here this time? Because that's also 5%. Raise your hand if you had the asymptote in there. Awesome. So that's half the class, at least better than last time, but it needs an asymptote this way. Just to clarify, where is that asymptote? Is that an x equals or a y equals thing? I got a hint for you. It's on the y-axis, and it's kind of counterintuitive. X equals 0. Okay, so that's the equation. X equals 0 is the asymptote line there. Okay, now, what if we had actually get one of these and it was a little more complicated? Let's say it's been moved and stretched. So, y equals log base 2 of x, and this one's been stretched and it's twice as tall, so there's a 2 in the front, and let's say I move it to the right 3 spots. No, I'd be left right 3 spots. There we go. Now, I think you know generally how it looks. I'm sure you could sketch it if you move it to the right and you stretch it. I mean, that'd be pretty easy. Here's move to the right 3 spots, and then here's stretched. Higher than it was. You generally should know it's right there. But if you try to do it like that, you will get it wrong on your test because you have to have points. If you just have a general sketch, it's a sketching test. This is a graphing test. So, how do I graph this puppy? We know that the end result is supposed to generally be, let me get that red one out there. Supposed to generally be something like that. Make an XY chart. And this is where it's crucial, is you have to be able to grind out the math. This isn't just super simple. We got to pick things that are going to work nice for us. And let's start with, do you remember me saying if you won the argument, that's the argument spot. If you make that equal 1, you'll have won the argument and you get what? 0. And 0 is a good number because then 2 times 0 will still be 0, right? So how do we make the argument 1? If x was what? If x is 4. See, a lot of people think, oh, I'm going to make x 1 and then I'll won the argument. You need 4 here to make 4 minus 3, so the whole thing becomes 1, and then when you've won the argument, the whole thing's 0. 4 comma 0 is on your graph. Now look at our graph. Doesn't it make sense that 4 comma 0 should be on the graph? It's right kind of where we expected. We expected it to be there. All right, the next one. Making the argument 1 is a great strategy, but then that won't get you enough points. You got to get you 1 point. What else could we make that would make this work nice? If the thing I circled was equal to a total of what? This area right here. Total of what? Total of 2. Awesome. Why 2? Because if this is the same as this, then the answer is the exponent on it. Do you remember that? If we have log base 7 of 7, the answer is 1. Remember that? So, in this case, we have log base 2. And if we had log base 2 of 2, the answer would be 1, and that would be nice. So, what do we need to put there to make it equal 2? A 5. 5 minus 3 will give us 2. Put 5 right here. And now I have 2 there. Now I have log base 2 of 2, which equals 1. Final answer. 2 times the 1 is 2. 5 comma 2. Now, look at my graph. Doesn't it make sense? If this was over 4 and up 0, and this is up over 5 and up 2, doesn't that make some sense? It's like fitting, kind of what I predicted it would be. That's critical. Because, see, a lot of times kids are making a mistake, and let's say they're putting their answer over here. They don't even think to check it with what it should be. If we know this should be to the right 3 and twice as high, and you're getting points over here, you should be like, wait a minute, that's not to the right 3, that's to the left 3. I must be doing something wrong. It's critical that you check yourself. So make an XY chart and think about where should this thing be. It seems like it should be to the right and should be stretched up. And if my answer isn't in the right spot, I will fix it. Yes, sir. You're right, I'm not done yet. I'm not done yet. So the last and most important thing is the asymptote. Because if you get the asymptote right, like if I know the asymptote's going to be like right here, then you know the graph has to be right near that, right? Because the things get closer and closer to the asymptote. So that'll be critical. How do you get the asymptote spot? Well, what's the asymptote on a normal graph, like y equals log base 2 of x? Where's the asymptote always? 0. Starts at 0, right? Okay. It started at 0, and I moved it to the right 3. That minus 3 meant moved it to the right 3. Do you get how the asymptote is going to be at x equals 3? Now, what is that? That's the thing that makes the argument 0. But you say, Mr. Server, you said we couldn't have zeros right here. You're right. Why can't we have a 0 right there? Because it makes an asymptote. An asymptote on the graph means nothing exists there. Remember, an asymptote is saying it doesn't work on this line. That's what the point of an asymptote is. So, because we've made the argument 0 by putting a 3 right there, see, then this gives us the asymptote. It does not give us an answer. If you make the argument 0, you've got the asymptote. I'm sure you could make up some snappy saying about arguments in 0 and being an asymptote. But I have made up mine. You make up your own for that one. Mine was if you won the argument, you get 0. In this case, if it's you make the argument 0, then you're an asymptote. Okay. Let's try one more topic, and that would be if I have something that's a little more complicated with negatives and everything, and I don't give you any help. So if I just say like negative 4 to the x plus 5, can you graph that? My advice to you is make an XY chart. Try to figure out, oh, this thing's been flipped this way, and it's been moved that way. And make a sketch for yourself. The first thing I would do is make a sketch. You know where it's supposed to generally be. But you know a sketch alone won't get you credit on a graphing test. Make a sketch. I know, that's an exponential. Oh, so it generally looks like this, but then it's been flipped this way, and it's been moved that way, and then make an XY chart, and then graph it. I'm going to pause for a second. I want to give that one a shot. Okay, here's some thoughts. First of all, anybody can sketch this thing if they know that that is a vertical reflect, and that's a left 5. And then what order should they be in? They're on the outside, and so the vertical reflect should happen first. So started this way, vertical reflect, up-down reflect means it goes like that. That's up-down reflection of my original one. And then the 5 to the left means this moves over like this. Up 5, not 5 to the left. Thank you. Up 5 means like that. Quite different. Okay, now, you know what would have happened, though? Once I made my XY chart, I'd have been like, wait a minute. All my dots are up there. You know what I mean? And I would have been able to catch that mistake in my XY chart. Either the XY chart can catch mistakes on the other thing, or the other thing can catch you making mistakes on your XY chart. So either way, I bet I would have caught it. But thank you for catching me. It's a good thing. I'm just saying that's why we do this. We check ourselves because it's so easy to make one little mistake like that. But if you double check yourself with the XY chart, you are like 98% sure you're right when you're all done. Okay, now I'm going to put in some numbers. I like putting things to 0 power because then that turns that whole term into what? A 1. So 1 plus the 5 then, 1 plus 5 makes 6. So 0 goes with 6. Over 0 up 6, look at that, just like you said. It was up there. Could it be negative? No, because, oh, wait a minute. This part right here would turn into 1, but then you're right, that negative is on the outside and it happens after the exponent. So you're right. That's a negative 1 plus 5, which would be a 4. Ooh, scary. So I went up too high. Oh, I could just cheat and say that was 4. There we go. Okay, but you can see how that mistake could have been made easily. I bet a lot of you did that, in fact. All right, so why is it that way? Because if you put the 0 here, this turns into 1. Not everything turns into 1. That turns into 1. And then this negative that's on the outside turns it into negative 1. Plus 5 makes positive 4. Thank you. 2 people have caught me in a row. I'm off tragically. All right, so we now know that 0, comma 4 is on my graph. Now I got to figure out where the rest of it is, and I know generally it's going down like that. At least I think it is. Let's find out. Now it's another thing easy to put in. How about 1? 4 to the 1 is 4, and then I make it negative, and that's going to make it negative 4, plus 5 makes positive 1. So 1, 1. Is that, did I do that right? Did anybody else have 1, 1 on their chart? Okay, good. Do you see how my sketch is off tragically? Because 1, 1 doesn't look like it's on my sketch, but okay, I guess it must have been a much sharper turn than I thought it was going to be. Okay, let's try another point. Let's say 2. This is going to get a little crazy because 4 squared is 16. Then I make it negative. Negative 16 plus 5. Negative 16 plus 5 makes negative 11. Did anybody have 2 negative 11 on their chart? All right, good. At least I can verify that that's a valid point. 2 comma negative 11 is way down there, and I guess it's just sharper than I thought before. Would you have had all those points? Nope. This one's probably off your graph. You wouldn't have had to have that one. And last thought is, where is it, like, getting closer and closer to? You see how my asymptote's missing? So where is the asymptote on this thing? The asymptote is what would make this thing not, like, exist. In the original, the asymptote was here. And the parent, oh, it's up there. The asymptote's, like, right there on that line. So when we flipped and moved it up, how far up did we move it? This tells me where the asymptote moved to then. The asymptote was at 0. It's always at 0, whether it's an x-asymptote or a y-asymptote. It starts at 0. And then that moved it up 5. So, asymptote across here at 5. All the more reason that that can't possibly be a 6 right here. It has to be less than 5 because the asymptote's at 5. All right. So, all said and done, this blue sketch is turning into a graph. Why? Because it's got at least 2 points on it. And it's got the right curve, and it's got the asymptote on it. How many of you would have had it correct on the test? All right. That's only 2 people, 3 people. Is it that 6th thing that got you? Or was it that you weren't doing this and then making it negative? Was it that? Yeah, I'm seeing some people nodding their head that they weren't doing that in the right order. All right, let's do another one like that then. Y equals negative 2 to the x. This time I'm going to make the move up in here, minus 3. Notice that is not a down 3. That would be if it said minus 3 down here. Make me a sketch of that. Okay, so see how you did on this one. XY chart, sketch. I really think both are important. If you just trust whatever you do in the XY chart, then when you have something like this negative that you might be messing up, you won't even know it unless you kind of know where it's supposed to go. I know 2 to the x is an exponential. Looks kind of like that. I know the asymptote with it is right there. Now, where's it going to go now? That's an up-down reflect. So the asymptote stays in the same spot, but now it's like this. Then the -3 on the inside, horizontal on the inside, you know, the high-vo thing. This is the vertical on the outside thing. The horizontal on the inside, that's a horizontal as in right, left, right shift of 3. So this red graph goes over 3 spots. Fortunately, I picked up the marker. Here, I'll just cheat and move this to the left. Now that looks a lot like it was in the first place. It's just when you do left-right shifts on these, it's kind of hard to tell. Okay, so my XY chart now. Let's see if it looks like it's generally in the right spot, but maybe I'll be more exact with these points here. So I'm going to pick some things that work nice. Up in there, I'd say a 3 would be nice to put in for x. And that gives you a power of 0. Just like last time, you got to be careful though. That to the power of 0 makes 1, and then it becomes negative. Negative 1. Raise your hand if you had 3 negative 1 on your chart. Good. So over 3 and down 1. Looks to me like we're kind of on the right track here. Next, let's put in something like, if I make the exponent into a 1, that wouldn't be too bad. So how about if I put in a 4 for x? Now my exponent's 1. Remember, it does not have a parenthesis around that negative. So this is done first. 2 to the 1 power is 2. Then I apply the negative, negative 2. 4, 1, 2, 3, 4, comma, negative 2. Looks like it went down a little steeper than I had it. Seems to be a common theme. When I make my sketches, I'm not making them steep enough. There. And now, where would the asymptote be? Still here. Asymptote's still on that line, which would be, since it's the x-axis, y equals 0. Okay, so my sketch, this red one was pretty crappy. My green one is much more accurate. It's got 2 points, got the asymptote in there. How many of you would have had that one right? We've moved up to 2/3 of the class from 2 people last time. All right, and let's do one last log. Remember log base E? Except I'm going to make it a 2 in the front and go -5. Remember, you can use E is like 2.718. Generally, do you know that logs are like a tree blown over in the wind? There we go. Should look kind of like that, except it's been stretched and moved up or down. Pause for a second, let me try that one. Okay, for those of you that are gone today for AP and IB testing, I handed out the review packet for today. It says Review for Graphing Assessment number 5. You can find it on the Google Drive. Review for Graphing Assessment number 5. All right, so here's some points we should have picked and where it generally should be. This is generally what logs look like. Then this one's been stretched twice as tall. Okay, so that means that it's taller than it was. Now, it might have been off in the first place, but I'm generally making it taller. And then this means right 5. Down 5. Dang, I keep doing that. I complain when the kids do it, but I keep doing it myself. There we go. Okay, now, I know that's totally just a sketch. But if my points end up coming out like here, I'll know, wait a minute, something's wrong. You know what I mean? And I'll have to double check either my assumptions are wrong or I'm typing my numbers into the XY chart wrong or something. Okay, so some things that would work nice. If that was an E, do you get how if these two are the same, then the answer to this block right here is it's equal to 1? That's a critical thing to get. If these two are the same, you always want to make that one of your choices. So if I'm saying that x needs to be e, then x is e, also known as 2.718. Are you going to be able to put e into a graph? No, but 2.718, you're about 3. 2.7, you can put that on a graph. All right, so anyway, this comes out to equal 1 then. So then I go 2 times 1, which is 2, and then the 2 minus the 5 makes negative 3. E and negative 3. That's a point. Now, what is E? 2.718. So 2.718 is about 3, and then down 3. So I was kind of close-ish, but something like that. Yes, sir? They're interchangeable. 2.718 or E are fine. I mean, 2.718 is a rounding, so E is technically a little bit better, but I get on the graph, you'd probably want to use 2.7 about. Okay, next. What's another thing that would work great if you won the argument? So x goes in instead of being an e, this time I want to make x equal 1. Because 1 the argument means you get 0. Everything turn into 0? No. This turns into a 0. Then 0 gets times by 2, which is still 0. And then I subtract 5 from it. 0 minus 5 is negative 5. 1 comma negative 5. I go over 1, down 5. Hey, it looks like I'm kind of on track on that. So now here's my better answer. It's got 2 points labeled, and I'm still going to lose 5%. Why? No asymptote. The asymptote, did it ever move? Nope. The asymptote was right here the whole time. And it would have moved if I'd have moved it left-right, but I only moved it up-down and stretched it, so the asymptote never moved. Questions? Okay. That's a good, thorough review of all the kinds of things you generally have to know how to do. And from here, I'm going to give a shorter review like this tomorrow. And your assignment for tonight is to take this packet, and why don't we just keep it simple and do problems, the front page, front and back of the front page. So that would technically get you up to problem 8 on the review packet tonight. You know what? Problem 1 has so many parts to it, I'm going to make it even a little shorter. Let's just do 1 through 6. 1 through 6 tonight. And then you can always do the rest tomorrow. That's all I have for the video for today. Good luck to those of you taking AB and IP tests. I hope they went well for you.